Okay, so find the derivative of the function, the natural log of the natural log of the absolute value of the cosine of x, and use this result to establish a formula for the integration of a trigonometric function. Now we'll see which trigonometric function, hopefully, when we get to the end of the problem. Now, you may be wondering why we have the absolute value bars on the arguments of the natural log function. Well, recall you can't take the natural log of a negative number, and you also can't take the natural log of 0. So at least the absolute value bars extends the domain of this natural log function as close to all real numbers as possible, but not all real numbers, because x cannot equal pi over 2, because the cosine of pi over 2 is 0, plus, we'll say plus n pi, any whole number, any integer multiple of pi. Okay, so those are the values where the cosine function is 0, or this natural log function f of x is undefined. And we also know that the chain rule version of the derivative of the natural log function, the derivative with respect to x of ln of u, where u is some function of x, is equal to u prime over u. Okay, so let's take the derivative. Switch over here. Let's take the derivative of the natural log of the absolute value of cosine of x. And we'll do a little u-substitution here. We don't actually have to write it out, but we'll call this u. Let's say u is equal to cosine of x, which means u prime is equal to negative sine of x. Okay, so our derivative should equal u prime negative sine of x over u, which is cosine of x, and we know that sine over cosine is equal to tangent, so the derivative is equal to negative tangent of x. Here is our derivative. The derivative of natural log of the absolute value of cosine of x is equal to negative tangent of x. And this aligns with our domain of the original natural log function, because also the tangent function is undefined when the cosine function is equal to 0. The tangent function has a vertical asymptote when the cosine function has an x-intercept. All right, so those domains align and everything looks fine. And now we know that if we could take the derivative of a function, we could take the antiderivative of the resulting function. So based on this result, the antiderivative, or the indefinite integral of the tangent of x. Well, let's put this negative sign. If we know the derivative of ln of absolute value of cosine of x is negative tangent, well, then the derivative of negative ln of absolute value of cosine of x should equal positive tangent of x. So the antiderivative of tangent is negative natural log of the absolute value of the cosine of x, and don't forget, plus c plus our constant of integration. Okay, so we have now established the formula for the antiderivative of the tangent function. Now, this is not the only way we could have done this. We could have done a u-substitution, and we could have said the antiderivative of the tangent of x dx is equal to the antiderivative of sine x over cosine of x dx, and we could have done a u-substitution here. We would have got the same result. Either way, the antiderivative of the tangent function is negative natural log of the absolute value of the cosine of x plus c.